In this video, I will show you how to use a crystallizer in Aspen. We are going to use this crystallizer to crystallize salicylic acid out of benzene. To start, we're going to use a new simulation and we're going to add our components. The first component we're going to add is salicylic acid. And what we're going to do is we're going to need to add salicylic acid twice. And for one of these versions of salicylic acid, we're actually going to change this type column so that it's actually solid. Because in this simulation, we're going to have both solid salicylic acid as well as aqueous salicylic acid in solution. In order to differentiate this, we're going to rename one of them as with S to denote that it's solid. And then for our crystallizing medium, we're going to be using benzene. Once we have them added, we can choose our property methods, which in this case we're going to use the solids property method, since we are working with solids. We can run our properties to make sure that we don't get any errors, and then we can move on to the simulation. Once in the simulation, we're going to go into the solids tab, and we're going to add a crystallizer. For the crystallizer, we're going to have one stream that's going in, and we're going to have two streams that are coming out. Now, to make this easier, we're going to go into our setup tab, and we're actually going to change this to be on a mass flow basis. But the important thing is actually that we change the stream class, because right now it's set to conventional by default. We actually want to change it to mix CIPSD, which allows us to have a solid and liquid mix stream with a particle size distribution. Once we have our setup done, we can now select our feed stream, and we can set our feed to be at 65 Celsius at 1 bar, running 12,000 kilograms per hour of our feed stream. And we're going to set it up so that we have an input stream that's 3% salicylic acid by mass in benzene. Once we have our feed stream set up, we can move on to the crystallizer. For the crystallizer itself, we're going to have it operating at 0 Celsius and 1 bar. This means that it's going to cool the feed stream to 0 Celsius in order to do crystallization. We can use a crystallizer in a number of ways, by utilizing either solubility data, a solubility function, chemistry, or a user-defined subroutine. For the purpose of this, we're going to be using solubility data. For this simulation, we're going to select our crystallizing component as aqueous salicylic acid, which would have a component of -1. And the crystal product will be salicylic acid solid, which is in the mixed solid and liquid substream, with a coefficient of +1. All that's left is to input our solubility data. For our solubility data, we're going to do this on a solvent basis in this case. And in this case, our solvent is benzene. And I'm just going to input the solubility data that I have for salicylic acid and benzene. The last thing that's needed to run the crystallizer is that we need a particle size distribution, which we can do in a number of ways. We can copy it from the inlet, we can calculate it using growth kinetics or a particle growth model, or we can define it ourselves. In this case, I'll use a user-defined particle size distribution. First, I'll specify a crystallizer volume, which in this case is going to be 1,000 liters, and then select user-defined PSD. From here, I'll go to distribution function ID and click new, and I'll just enter it as 1. In this case, I believe our particle distribution will be normal, so I'm going to choose a normal distribution. And I'm going to choose it to start from D50, using standard deviation. For salicylic acid, we expect our D50 to be 1000 microns, or sorry, 100 microns. And our standard deviation is going to be 10 microns. From here, our crystallizer is fully set up. However, in our product stream, we will not be able to see the crystal size distribution unless we create a mesh that allows us to see the data outputted for the crystal size distribution. In order to do this, we're going to go back up to the setup folder, and we're going to open it, and we're going to go to solids. And we're going to select this input option called PSD. Once we're in this PSD window, we're able to create a mesh that allows us to see our data as an output in the stream summary. Without this mesh, we wouldn't be able to see any of the particle size distribution that we have defined. For this mesh, I'm going to choose to do a equidistant mesh. And we know that our particle size distribution has a center point of 100 microns and a standard deviation of 10 microns. So for this mesh, I'm going to define the lower limit as 0 and the upper limit as 200. And I'm going to select to make it have 20 intervals so that it should create a particle size distribution mesh that shows every 10 values, that shows every 10 microns from 0 to 200. From here, we should be able to run our simulation. Now that our simulation has been successfully run, we can look at the stream results from our crystallizer. If we look at the mass fractions of our feed streams and our product streams, we can see that while we initially had 3% aqueous salicylic acid, now 2.8% of this now 2.8% of the stream is actually solid salicylic acid. If we scroll down further and we look at the CIPSD substream class, and we can look at the particle size distribution of the solids in our stream. Since the feed stream did not have any solids, it makes sense that we don't see anything there. But then if we look at the particle size distribution of our liquor stream, we can see the particle size distribution of the salicylic acid in our benzene stream.